Hello everyone, thanks for coming to my talk, thanks for tuning in. Today we're going to talk about passwords, password managers, blocking password managers, and unblocking password managers. My name is Ignat, I'm from Cloudflare. So a little bit about myself first. I do performance and security at Cloudflare. I'm passionate about security and crypto, and I also enjoy low-level programming, things like Linux kernel, bootloaders, and other low-level scary stuff. But today we're going to talk about passwords, and it will be in a form of a story. So, well, passwords are probably the oldest and still the most widely used pillar of authentication. The first mention of passwords are dating back from the old Roman Empire, where it was called watchwords at that point. So where Roman military shifts have this watchword to authenticate each other during a shift change. And Romans actually had a very sophisticated password management scheme. So they rotated these words, so they had a daily watchword rotation and other interesting things. And even if it's the oldest pillar of authentication, today it's still very much important, because probably 75% of all the authentication on the modern web is done via passwords. Yeah, you may argue that these days we have more sophisticated authentication scheme. We have two-factor authentication, we have cryptographic key authentication. But if you take a closer look, we still use passwords in all of them. Like in many two-factor authentication schemes, one of the factors is still a password. If you SSH into production with an SSH key, the private part of your SSH keys most likely is protected via password as well. So passwords are still a part of the modern authentication schemes, and they will probably stay with us for a long time. And because passwords are so popular to protect secrets, there are many passwords attacks where malicious attackers try to obtain the passwords. And if we try to categorize them, like the most common attacks can be broken down into brute force attacks, probably dictionary attacks, and services account hijacked and leaks. So what is a password brute force attack? The attack itself is not very sophisticated. In a brute force attack, what the attacker does, they just design a way how to try every possible combination, and basically they try to guess the password by trying every possible password ever. It's not that the technique is not sophisticated, and it's very resource consuming, so the longer the password requirement is, the harder it is to mount that password brute force attack. The second category is dictionary attacks, and it's definitely not what you see on the slide. So dictionary attack is slightly different. So in dictionary attack, the attacker tries to make the attack more complicated, more sophisticated, by exploiting the fact that humans do not just choose random characters for their password. They are most likely to choose specific words, and moreover, humans are likely to choose some words but not the other words. So in a dictionary attack, the attacker compiles a list of all the words that are most likely to be chosen as a password. There are statistics around that. They call it a dictionary, and basically they don't try each password manually, though. They design some kind of automation, like a login script, which takes this list on input and tries every word from that list on a specific application or service the attacker wants to get access to. Yeah, and the third category is services account hijacked or leaks, which can be further broken down into client-side attacks, which may include phishing emails. You as a user can receive an email from an attacker pretending to be from the support, customer support of your service, and they can try to convince you to give up your password. They can also similarly do like insecure fake web pages which have the same look and feel as your servers, and try to convince you to visit those pages, and when you try to log in on their website, you are actually like leaking the password to them. And finally, there is social engineering aspect. They can call your phone and pretend to be some kind of like from support of your bank and try to persuade you to give away your password. There are also server-side leaks. So every service has some kind of databases or user database, and sometimes these databases leak alongside with the password. We also have code vulnerabilities. Think about like insecure WordPress installation, or if the attacker is someone able to inject JavaScript onto a third-party web page, which can steal the password from the login form. There is also social engineering aspect from the service side, where an attacker can call customer support of the service pretending to be the CEO of their most valued enterprise client and to be very frustrated and persuade them to do something with what they shouldn't do. So if you take into account all these potential password attacking techniques, modern passwords, to be secure, they need to meet a specific set of security requirements. So modern passwords, they need to be long to protect yourself from brute force attack. They also need to be random-like to protect yourself from dictionary attacks. They should be hard to guess to protect yourself from both, actually. And what more important, you should never use the same password for different services, because the attackers are likely to take the least resistance approach. If you use the same password on two services, let's say on Gmail and some not very important local utility bill provider, most likely your utility bill provider does not have very sophisticated technique, or they're less trained to be protected from social engineering attacks. And let's say the attacker will try to hijack your local utility bill provider first and get your password, and then they will try to use the same password on all the other services you use, like which have better security requirements like Gmail or Twitter or whatnot. But what all these requirements means for passwords complexity. So long means it's hard to remember, right? Random-like, it means it's hard to remember. Hard to guess, it means it's hard to remember. And never used for n-side, it means it's n times hard to remember, because now you have to come up with this secure password for each web service you use. And in reality, as more sophisticated password attacks are developed, the passwords are becoming more and more complex. And at this point, it's almost unmanageable to remember all your secure passwords. So for example, this is an extract from RFC 7616, RFC being an internet standard which describes HTTP digest authentication, which is basically a password authentication on the web. And what it says is digest authentication should be used only with passwords that have a reasonable amount of entropy, example 128-bit or more. Such passwords typically cannot be memorized by humans, but can be used for automated web services. So even an internet standard tells us that modern secure passwords cannot be memorized by humans. Yet, and this is like HTTP digest authentication, many websites use a simpler form of so-called HTTP basic authentication. But we use both every day on the web. Luckily, there is a way out of this ever-growing password complexity, which is called a password manager, which is specific tools to protect all your passwords. So what a password manager is, imagine you're using, like, let's say 3 different web services, and remember we have the requirement that each service should have its own unique password, so you have these 3 passwords, but you don't have to remember all of them. What you can do is you can take a database, and in password manager terminology it's called a vault, and basically just store your password in this database. And because computers are much better at remembering complex things than humans, so like let the computer remember your password, but you also want to store to protect your database, so that's why you come up with only one very secure password, which is called the master password. And what password manager will do, it will convert your master password to a cryptographic key and will use that key to encrypt the database. That's how password managers protect your password. So only you, because only you know the master password, only you can decrypt the database, thus get all the other passwords and all the services. So with password managers, the advantage is you have to remember only one password, and your service passwords can be as complex as required, right? Because you don't have to remember them, computers will remember very complex passwords. They can be long, random, like with symbols, whatever you want, and emojis even. And yeah, your passwords are totally random, so you're protected from dictionary attacks. You don't have to use real words, because computers do not care if they remember words or just random characters. And it's very simple and easy to use. Yeah, so basically that's it. We solved the password complexity of the modern world, and thanks for listening. See you next year. Right, so, but unfortunately it's not that simple. So we almost have solved the problem of complex passwords, complex secure passwords with the password manager, but there seems to appear a trend where service owners try to block you out from using a password manager. So this is a typical, I don't know, project manager or senior architect or whatnot, and we started to see many instances where service owners block copy-paste into the password fields, because the primary assumption of a password manager usability is when you decrypt your vault, when you get access to your service password, you need to copy-paste that password into the password input field on the service. But somehow these evil security architects are telling web developers to invent some code to block copy-paste for some weird security reason. Some time ago, a famous security researcher, Troy Hunt, made this research. He reached out to different website supports which block passwords, password pasting functionality, asking them for the reason, and he categorized common responses as to reason why the service owners do that. One of the most popular reason is service owners consider clipboard security questionable. So what they say is, we do that because users may be running a potential malware which can intercept the information from the clipboard. So this way they discourage users from copy-pasting their passwords. But it's not very clear why the same malware, that malware should have sufficient privileges to do so, and if the malware has these privileges, does the malware not have the privilege of just intercepting keystrokes when the user types in the password? So it's a bit of a questionable security concern, right? Second reason is they say it protects them from password brute forcing. So they think that surely hackers brute force passwords by quickly copy-pasting them into a real browser, and blocking copy-paste will help that. So they imagine that the hackers are like that. So surely, in reality, attackers will likely use an automated headless system to actually feed the passwords into the service itself. So it's a questionable concern. Some say it's just compliance requirement, but if you follow up with the questions, all these compliance requirements are public, and you point which one specifically tell you to do so, and you never receive a response, because in reality there are no compliance, at least known compliance requirements, which tell application developers to explicitly block paste functionality. And more obscure one, because this is our procedure, it's for your security, some say it just can't work otherwise, or because we can, is a typical developer response. Fortunately, there is some rebel movement organizing against these evil websites which block paste functionality, thus blocking you from using a password manager. And there are ways you can counteract these evil websites. So one way is, if you're using a Firefox web browser, you can just basically set this config option. What it does is it tells your browser not to emit on copy, on cut, and on paste events to the JavaScript on your websites. And it's basically, there are no extra dependencies, you don't have to install anything, it's easy. Although it's somewhat not reliable, so you block these 3 events, but some clever developers come up with some more sophisticated JavaScript which may use onKey press event, for instance, and they can still block the password paste. It's obviously not portable because it's a Firefox feature, so if you're not using Firefox, you're out of luck. And also it can break other functionality. So modern web applications are quite extensively using JavaScript for their primary functionality, so they're quite responsive. And if you just block emitting some JavaScript events which may be required for other website or application functionality, the application may not work. So essentially, this approach is basically cracking a nut with a sledgehammer, right? So you want to disable one small thing, but you take down the whole subsystem for that. Second way is there are different browser extensions that exist to unblock block paste functionality. So some of them, the way how they work is some of they inject even more JavaScript, which tries to counteract or override the paste blocking JavaScript in the application itself. So they're more likely they're third-party extensions, and what they implement is actually they try to unblock paste functionality. The other type of browser extensions, they can directly manipulate your document object model as you browse the web pages and try to inject your password values directly into password input fields. Because these extensions they require access to your password manager, these extensions are typically provided by the password manager vendors themselves. So the passwords appear to be pre-filled when you load the page. So the pros for this method is, they're kind of easy to install. Most of them, most modern browsers have some kind of web store, and just go there and pick that extension from the web store. They usually require 0 configuration. There are downsides, of course. They may not be reliable. They may not, because they emit JavaScript which tries to counteract the blocking JavaScript. They may not cover all the cases or all the potential ways the application developers can try to block paste functionality. They're also not portable, so these extensions are usually available for Firefox and Chrome. If you're using a Safari or some other browser which is more rare on the internet, you're most likely out of luck. And again, because they mess with the document object model of your browsing data, they can break other functionality. For me specifically, there are more security concerns around these third-party extensions. So think about that. For example, if you try to install one of the most popular paste unblocking extension in Chrome, you will get a warning from your browser like this, which says that the extension you're about to install can read and change all data on the websites that you visit. So basically, by design, these extensions have full access to manipulate your document object model or JavaScript code, so they can inject or remove from your browsing data anything they want. And again, remember, because it happens inside the browser, this processing happens after the TLS termination, so the green lock in the browser will not save you, that these extensions still have access to your unencrypted browsing data. And secondly, because they are browser extensions, they run in the browser. Therefore, they have full network access because the browser needs network access to access the internet. And moreover, they may have legitimate reasons to have network access, because if it's, for example, a password manager extension, it needs network access to sync your passwords from I don't know, from the cloud backup or something. So yeah, think again about these third-party extensions. So you're installing third-party code which can read and manipulate all your browsing data and have full network access. So what could possibly go wrong here, right? Even if the developers of these extensions are not malicious themselves, there are many instances where these extensions might be hijacked and basically the attackers can get access to your data. So this is not a very great solution, in my opinion, to unblock you want to become more secure, but actually by using these third-party extensions, you open yourself to some other attack vector. So yeah, I'm actually not a web developer, I'm a systems engineer, and when I think about this problem, I try to think, oh, can the operating system actually help me with that? So it seems wrong that my own computer, my own system, my own operating system runs some web application code, and that web application code dictates me what can or can't I do. So can I just override this with my operating system? And yeah, and I consider there is a hope that operating system can do that. So, and I develop a tool for that. Let's take a step back and think again how traditional third-party extensions try to unblock paste functionality. So basically, you have a website or a service, and the service basically and then you have the users, of course. So these users can basically either type in the password on the login form, or they can paste the password from the password manager, for example. And what these websites implement with JavaScript, they from a high-level perspective, they try to implement some kind of filter where that filter tries to detect the pasting activity and block it, but that filter also should allow the typing activity, because users by design should be able to type in the password and log into the web application. So the way how these third-party or password manager browser extensions work is they basically try to somehow disable this filter. They try to mess with the filter and disable it, and to allow users to paste the password. With operating system level paste unblock, we take a different approach. Instead of trying to subvert the application's filter to block paste, what we just do, instead of pasting our password directly into the login form of the application, we paste our password into the operating system. We pass it to the operating system, and operating system on our behalf just types that password in. So from the application perspective, there is no difference either it's user types in the password or the operating system types in the password. It's basically that the operating system provides some typing activity, so that filter just cannot easily block it, because for the application itself it appears as someone is typing the password, and that filter should allow this by design. So yeah, I wrote a simple tool for that, introducing passkb. So imagine you have this website which tries to block paste functionality. You are the user. So instead of pasting the password into the website, you paste it into my command line tool, and under the hood the command line tool will use the special dev input Linux interface if running on Linux, or it will use the send input Windows API function if running on Windows, both of which will type the password directly into the web application. Here I have a small demo of the workflow, how it looks like. So in this demo I use a dev website which basically emulates two most popular password blocking techniques in JavaScript. So we see there is a green field which allows copy paste, and two red fields which block copy paste, but they do it via different approaches. So so here I have a crappy password manager, which is a simple text file. So I copy my password here and I try to paste it into the website. So in the green field I can do it because there are no restrictions, but when I try to do it on the red fields, the copy paste doesn't work. So instead I start my tool and copy paste the password there, and I have 5 seconds to return the cursor back into the web application, and in 5 seconds the operating system types it in. Let's try a different blocking technique. So again, paste the password, return the cursor to the field, and the operating system types it in. So that's as simple as that. There are some specifics if you're running the tool on Linux. So on Linux, the passkb, as I mentioned, uses the special dev input device file to emulate keystrokes, and the process actually requires read-write access to the device files. But on most Linux distributions, this file is owned by root by default with 600 access mask, so you can't run it as a normal user normally. So what can you do? There are several approaches. A simple one, you can run it as a super user. This is not recommended because you violate the least privilege principle. So better, you can basically change the ownership of the file to yourself, so you can declare yourself as an owner of the file. This is good if you are the only human user of the system, because if your computer has many users and all of them want to use this tool, it will work only for the one owner user, right? And the best way is basically the recommended way to create a dedicated group for that. Add all the users which want to use this tool to that group, and change the ownership of the special file to the group, and modify the access mask to 660. And remember, the device file system is an ephemeral file system, so any changes you make will disappear on reboot. So to make your changes persistent, you will need to do this either in some kind of udev rule or a startup script which restores these permissions on each board. So the pros of the tool is obvious. The tool is cross-platform and browser independent. It works on any browser and beyond. Because it's a separate tool from the browser, it doesn't even care where it types the password. And even if you have a let's say, a fat binary application with a login form which also blocks pasting functionality for whatever reason, you can use my tool with that application as well. Because it's a separate tool, it runs in a separate process. By design, it has no access to your browsing data, right? Because that's how processes work on most modern operating systems. It also has no network access. The tool is open source. You can verify it never uploads your passwords anywhere. And moreover, because it's a separate process, you can further use operating system primitives to sandbox the tool, put it in a container, put it in a jail, and only allow it to access the needed APIs and interfaces, and fully block the network access through the operating system. It will still work. And again, it's a separate constrained process. Many third-party extensions or password managers provide you with extra functionality, which is usually a source of security vulnerabilities. This tool is just simple, which types in passwords, and it follows a Unix do-one-thing philosophy. And it's simple and reliable. There are no settings, there are no states, there are no heuristics, regex to configure, so it doesn't care. It doesn't try to manipulate your document object model. It doesn't try to find the paste block in JavaScript. It has none of that. And most importantly, it cannot be detected or blocked by the application, because from the application perspective, it can't tell the difference that the typing happens either from the user actually pressing the keystrokes, or the typing is done by the operating system itself, because from the application perspective, it's the same thing. There are, of course, some downsides as well. It doesn't work on macOS yet, and help wanted. If you can make it work on Mac, please send a pull request. It doesn't work on mobile devices probably because mobile devices have a different workflow, and modern mobile operating system like iOS and Android already have the relevant interfaces and setups to make password managers work, so it's probably even not needed there. There is also this usability, as you saw from the demo. We need to run a terminal alongside the browsing session. We also need to do some setup and configuration for the device file on Linux. And also, you saw the workflow. In order to paste the password, you need to switch windows, because you need to paste the password into the terminal and quickly switch the window back to your browser, put the cursor there so the operating system can type it in a proper place. That's basically it, what I wanted to say for today. So what can you do? If you're a user and you're still not using a password manager to protect your password, you should really start using one. If you're a web developer, please reconsider messing with paste or blocking password paste functionality. It will not make your website more secure. It will probably make your users less secure. And if you're not coming up with this requirement yourself, but this requirement is brought by your evil PM or a security architect, challenge them and show them this presentation. Please use my tool, provide feedback. If you can, please make my tool work on Mac OS. And finally, spread the word. So with this tool, with this concept, there is no way an application can come up with any sophisticated JavaScript to block password paste anymore, because we use the operating system interface here, and there is no way from the browser you can tell if you're getting a password via paste or via typing, because it all appears as typing. So basically, at this point, this tool just shows that the paste wars are over, and basically the password managers won, because we can always bypass any sophisticated JavaScript which block paste with this approach. It's universal, and yeah. that's it. Here are some useful links. I'm again repeating the link to the Troy's Hunt blog post I mentioned earlier, which researches websites which block password-based functionality. The second link is just to make sure we're not imagining things and to give us more credibility. The second link is an official, is basically advice from an official government, UK government security agency to actually allow pasting passwords on website. So if you get if somebody says it's required on compliance, and for example they operate in UK, at least say that even the UK official government bodies recommend you not to block password pasting functionality. The third link is to the blog post which I used in the demo, which implements typical JavaScript paste blocking code. And finally, the fourth link is a link to my tool, which I presented here, to GitHub. It's open source. You can download it. Please send pull requests and please send feedback. Yeah, and finally, if you block paste on your web application, we will find you. Thank you for your attention. That's all I wanted to say. And basically, I'm ready. I should be online now and ready to answer all your questions.
Hello and welcome back. So Ignat, thank you for your talk. That's impressive research. Especially, I was amazed that you created the tool and it's open source and it works on both like Windows and Linux. I was actually going to ask if it works on Windows too, but then I read it in description. So like, wow, you did a great job. Why do you think it doesn't work on macOS? Sorry, I missed
that. It should work. The thing is, I don't know the places to use, and Stack Overflow didn't help me. So I kind of found some like examples of the functionality I need, but it was some obscure functionality from a low quality script, which I was reluctant to adopt, and I didn't find any better way to interact with the operating system to send keystrokes. So yeah, if I have of all the development experience, I have the least one with Mac. So I'll either need to do more research or wait for someone to help me with that.
Thank you. I've sent on YouTube, I sent the link, a way how to find your tool. So people, if you're watching stream, check it out and try to go to on GitHub and put a star, because obviously open source software should be, promoted. Thank you. We have actually a bunch of questions. What are your thoughts about browser extensions provided by well-known password manager? Do you think they're safe to use?
Generally, yes, but it depends. So, I trust the extensions from password managers more, but the security research somehow shows otherwise. I remember there was a research about security of these third-party extensions for different password managers like LastPass, 1Password, and many others, and all of them were vulnerable to some kind of attack. And the main reason comes from the fact that, especially commercial password managers, they don't want only to give you the primary functionality to store password. They want to sell you these premium features, and these features are most likely complex and they need some code to implement. So the vulnerabilities usually creep in that code. So most of the vulnerabilities reported in the official password manager extensions were due to the implementation of these premium features. That's why sometimes you just want Unix philosophy, do one thing and do it well, right?
Yeah, I agree. Talking about password managers, what are your recommendations regarding using password managers inside the team of admins or somehow of IT technology teams? What password managers would you recommend?
Most popular ones are good, in my opinion. It all depends on your requirements and probably uh, how far you want to go to. Like, there is always a compromise between usability and security. Some people prefer, like, oh, I will only use the open source password manager because I really want to understand like what's going behind the scenes and I want to compile it myself. But it also sometimes it lacks usability because you need to set up like a PGP encrypted stuff and then like do something with it. You have to have more understanding. Also, they don't, by default, they don't come with one of the most useful features as the cloud synchronization. So most of
Yeah,
us have
between all your
different devices.
devices. Yeah.
Yeah. So if you don't want to deal with all that stuff, maybe commercial password managers are better, like LastPass. They provide, even for free, they provide you with these basic features. And in enterprise, you can also basically, they allow you to share passwords between, like, let's say a team of admins. They can share password within the LastPass. Still, yes, you're relying on a third party for that, but at least like it's probably still be more secure than you will use a homegrown solution if you don't have the proper expertise in the field.
Do you use on your own a password manager?
Yes.
Which one?
I have an enterprise one and my local one. I mostly in enterprise we use LastPass and I quite like it. So uh, I would not comment on the security because it's still a proprietary solution. But so far, I have friends who work at LastPass, and I have like insider information that it's not malicious by design, at least.
So if anything happened, that's an honest mistakes, right?
Yes.
Okay, thank you. We have a comment regarding your tool, which part of questions I wanted to ask. So the comment is that your tool provides such a great functionality that it might make sense to integrate it into Password Manager. And the question is, do you plan to expand your tool? Maybe you want to build Password Manager around it?
I don't know, because if I do that, it will violate the Unix philosophy principle: do one thing and do it well. This tool is for typing whatever you paste in. If you add a password manager on top, you're adding like a whole bunch of things, like uh, password storage, the crypto, how do you implement the vault? Do you need a database? Do you do plain files, the cloud storage, and all of that? And probably it's better to just let the users decide for themselves what they want to use, because if you bundle it all together, users will likely be keen on using the tool and the password manager embedded rather than doing their own research and selecting what is best for them.
Yeah, that's true. That's true. Users are lazy and don't make good security decisions. I agree with you. Last recommendations for passwords, like for creating a strong password, is to use emoji in it. What do you think about it? Does it make sense, or it's just something like weird? Or next question, next question is: do modern sites, like a software, do they need to allow this password with emojis?
It's the same question, like why do some websites do not allow you to use special symbols, right? Which technically, if like if a website implements the password storage with the best of the state of the art, or I'd say like the general most recommended principle of hashing passwords, it shouldn't care, and they should not have any restrictions on the password size, because I many times I see a website that say like, oh, you can't have a password more than 12 characters. Like, why? Why do you care? You will still hash it to a single fixed byte array, right? So like, if I use like 1,000 symbols, you shouldn't care. But people have these requirements, so that may end up having like questionable security implementation. So if you see things that like you're not allowed to use emojis or special symbol, that probably is questionable. But again, it all depends on how the backend system stores the password. If of course they don't hash it and store it in clear text, and emoji might break some like database, and that's probably it.
But they deserve it, right? If they store password in clear text, they deserve it.
Yes. So before you do the official password with emoji, try to use the password drop users and see what happens.
You are evil. You're evil today. Thank you. We have one more question. As for paste battles, do you teach the companies that blocking of paste functionality is not a good way to cooperate with customers?
Well, like I didn't do it myself. I will refer you to the blog post of Troy Hunt back in 2014, and he has much more credibility around that, and still he had much trouble. I think it's kind of lost battle because if you're not directly working with these companies, or you're not like a security contractor, you're just going to their customer service, you get a canned response, and your
like thank you, your request is noted.
Yeah, most likely is not even being escalated to people who make the decisions. So like the person from the customer support responding, the best you can do is it's according to our internal policies, and but they don't fully understand why the policy states so. So yeah, I think it's a lost battle from here. If someone is working in the field like security consulting, they probably should check for these things and advise companies not to do that.
Do you think it would be wise if Google as a search engine will like lower the rank of these sites that disable paste?
Not really, because some sites are still quite useful, right? And like if people will not find the services, it will be not fair. And most likely, like how would Google do that? Like these logging pages, which might implement the blocking feature, might not be like the top page of the website, right? So and nobody's searching for logging pages, at least like unintentionally, right? So
Yeah, that's true.
It's rather questionable. What we can do is basically, that's why the password managers are more helpful. So if you encounter a website which doesn't allow you to like put emojis or special symbols in the password, I usually just generate a longer password, right? So you can compensate with the number of characters in the password. The most tricky ones are the ones who say not longer than 12 symbols and no emojis and no special characters. That's the ugliest ones, of course. But just having a unique password and like unique email for this website will probably protect from hijacking your identity.
In Cloudflare, if you do have the login pages, obviously you don't block paste in the password, do you?
No, not that I'm aware of.
So at least you can...
If we do, please let me know, and I'll send. And then, like you can bypass customer support, and you can let me know directly, and I'll make it like go away. But no, I'm using my password manager on my Cloudflare account, and it works. We even have two-factor authentication now.
And how long is your password? Typically.
Which one?
Okay, password for your work laptop.
I typically generate 16, not less than 16 character password.
Not less than 16 and no more than?
No upper limit.
No upper limit. Okay. This will help us to brute force. Thank you. No, I'm just curious. I'm just curious about that.
If
Okay.
you successfully brute force my 16-character random password, you deserve to have it.
I have honestly saying I have more fun things to do with my life, but I will consider that. Thank you. One last question we have for you. What browser do you use and recommend, and what browser you would never use?
I mostly use Chrome, but
Okay.
it's not because I consider it better for security. It's probably better for usability because it's the most popular browser and many things just work there and don't work in other browsers. Um, I do know that, like, specifically, like, I like the security of Chrome as well in terms of I know they put a lot of effort, at least in their V8 engine, which is like the Java's processing, and they like do a lot of security research, and they really have a really high bug bounty problem for any security issues reported there. So they put a lot of resources and make it insecure. So I would say, and it's mostly open source as well. So this probably ticks most boxes, more boxes than other browsers would tick for me.
Okay, thank you. I actually saw that there is one more. Okay, last of the last questions on YouTube. So let's assume that the company uses password manager for admin teams. But then when people are leaving those teams, how do you change all the passwords that the person who left had access to?
So in big enterprises, probably password authentication is not the best way forward at all. So if you have some kind of password authentication, you should really reconsider it. So any member who has some access, the system should be designed in a way where the access is easily revocable. And because people leave, like, you may suddenly get you need to have processes in place where, like, a person reports their phone was stolen, or they accidentally like leaked the password online, typed it into incorrect field, and you should be able to immediately react. So in this way, like, passwords are probably not the best way. It's like some key authentication which is based only like on authenticity, like digital signatures, and not on encryption, where you can just revoke the key, thus revoking any trust decisions around the key. And you can do it in a big enterprise because you are not limited to like, unlike like end users, which are only limited to what the service provides for them. You kind of like design your own system. But in a big enterprise, like access revocation should be really fast and efficient in my mind.
Yeah, like keep in mind all these like key management procedures, which we can say like access management procedures, right? Revocation, exploration, and all the things. Okay.
So just to give an example, I think Vault, like HashiCorp Vault, is on the right path here, where it can manage all the secrets for your internal resources, and like people just get like one-time access tokens or whatever, and they can be easily revoked as well.
Yeah. Makes sense. I hope the person who asked this question, I hope now you know how to build, an IT department in your enterprise and where to start from. Thank you, Ignat. These were all questions we had. This is a wonderful talk. I actually never thought about this topic really, really like a lot as you did. You explained so many examples, and I honestly never thought about that. And let's recommend something for our watchers. Can you give like one recommendation?
Don't reuse passwords ever. This is the most important bit. Even if they're weak, just never use them. And you can also check your passwords with Troy's Hunt have I been pwned project, which is quite useful. I think even modern services adopt his database, where if you even register with a previously leaked password, the service will warn you, and that's probably a nice thing.
Yeah, agree. I think Chrome actually uses a database in this in Chrome internal password manager, like built-in password manager. Okay, so people you heard, never use the passwords, use password managers, and make sure that you check and often rotate your passwords, especially if you found that they've been leaked somewhere.
Well, rotation is questionable though, because
Okay, don't rotate.
even yesterday, I think it was even Bruce Schneier, like he has an article about rotating password, like password fatigue rotation. So it's better not to have force users to rotate passwords in the long term, especially the ones they have to remember.
Because they will write it down on a paper behind keyboard. Yeah. Yeah, I hate those politics when they push you to rotate your password or like device pin code every 3 months. Come on, I will just add the number, like add 1, add 2, add 3, because there is no way how I will remember semi-random passwords.
Yep.
Okay, great. I believe this is a great closing of the first part of the second day of NoNameCon. Thank you, Ignat.